Hi, this is Dr. JMR Chemistry. Today I would like to explain about heat of vaporization. What is heat of vaporization? I'll give you with an example. For example, H2O తీసుకోండి. H2O means water. Suppose ఇక్కడ కింద L అని రాశారనుకోండి, that indicates liquid. It gives rise to H2O, means converted into gas, means vapor state. So here water is converted into vapor. At this stage, the amount of heat required to vaporize 1 mole of ఏం చెప్తాం జనరల్గా H2O 1 మోల్ని మనము ఒక స్టాండర్డ్గా తీసుకుంటే 1 mole of liquid into 1 mole of gas, that is nothing but vapor. So how much heat is required? That is known as heat of vaporization. So in this, how much energy is required? That is delta H, means vaporization, VAP. How much energy is required means plus 40.7 kilojoules of energy is required at 100 degrees centigrade. This is known as heat of vaporization. Once again, the amount of heat required to vaporize 1 mole of liquid into 1 mole of gas is known as heat of vaporization. So here the heat of vaporization of water at normal boiling point. So water boiling point is 100 degrees centigrade is 40.7 kilojoules per mole అని చెప్పొచ్చు. Here delta H, that is heat of vaporization, is positive in nature, then we can call it as endothermic reaction, means heat is absorbed. So means energy must be added to evaporate what liquid to gas ani ardham. So here suppose water that is in the form of gas, it is nothing but vapor. Naturally it is converted into, suppose H2O, it is nothing but it is converted into liquid form. So the same amount of heat is involved, means delta H is equals to minus 40.7 kilojoules per what you call mole at 100 degree centigrade. It is nothing but this we can call it as condensation, means gas is converted into water liquid. Gas is means delta H we can call it as negative. Delta H is negative, means we can call it as exothermic reaction, means energy is given off as the water condenses. So like this we are having different substances having different heat of vaporization. So for example, if you will take water naturally, so boiling point, normal boiling point is 100 degrees centigrade. At 100 degrees centigrade, heat of vaporization, that is 40.7, we can say delta H vaporization, it is nothing but 40.7 kilojoules per mole. Similarly, suppose you take isopropyl alcohol. We can take isopropyl alcohol. Same. So formula isopropyl CH3 CCH3, then here CH, then OH. This we can call it as isopropyl alcohol. So at what is the boiling point? Normal boiling point, that is 82.3 degrees centigrade. So here how much energy, heat of vaporization, that is 39.9 kilojoules per mole అని చెప్పొచ్చు. అలానే ఎసిటోన్ యు టేక్, ఎసిటోన్ ను చూసినట్టయితే CH3 then OCH3. This we can call it as acetone. Then here boiling point is 56.1 degree centigrade. Then here we'll get 29.1 kilojoules per mole. So here this we can call it as heat of vaporization. So we'll do some problems based on this. First problem, for example, 25 grams of water. 25 grams of water required how much heat of formation, means how much it is required, how much heat is absorbed. So that we will do. Generally, you know that 1 mole of water is nothing but that is required 40.7 kilojoules per mole. So here 1 mole means how many grams? Generally 1 mole is equals to 18 grams of water. 18 grams of water. So 1 mole of water means here 1 mole of water is nothing but 18 grams. So 1 mole of 18 grams is nothing but naturally 18 grams is equals to 18 grams. Indirectly 18 grams of water is equals to 40.7 kilojoules. So naturally, so here 18 grams of water required 40.7 kilojoules of energy. So here 25 grams of water required how much? So naturally 40.7 into 18, 40.8 here 1 minute. So here 40.7 into 25 divided by 18. That is nothing but you will get approximately 56.5 kilojoules of energy is required to vaporize 25 grams of water. So like that you have to do. Next problem, suppose for example I will give you another example also. Suppose here 155 kilojoules of heat is present. This much heat. So here the amount of water means how much water, how many, we can say how many how much amount of water is required to this much energy will vaporize, how many grams of water is evaporate. How you will do? So you know that 1 mole of water we required 40.7 kilojoules of energy. per mole. This is standard statement for pure water. So here indirectly you know that is 18 grams. 18 grams is equals to 1 mole. You know 1 mole of water is nothing but you know the molecular weight of water. Indirectly the 18 grams of water is equals to 40.7 kilojoules of energy is required. So here 155 kilojoules of energy means heat of vaporization. This much energy is present means how much amount of water will be evaporated. How you will do? It is 18 into 155. 18 into 155 divided by 40.7. Then finally you will get 68.6 grams of water. This much water. So here for the 68.6 grams of water, this many grams of what do you call required 155 kilojoules of energy. So like this you have to do. This is about what a heat of vaporization. Once again, finally, what is heat of vaporization? The amount of heat required to vaporize 1 mole of liquid is known as heat of vaporization. Generally, the heat of vaporization of water at its normal boiling point, that is 100 degrees centigrade, is 40.7 kilojoules per mole. This is standard. Thank you. This is Dr. JMR, JMR Chemistry. Please like, share and subscribe. Thank you.